This is GCSE Further Maths. We're on pure and differentiation, and we're looking at then dy by dx as the gradient. So the previous video we were finding the gradient at particular points. Now we're going to do that backwards. If you know the gradient, we can work backwards to find the point which has this gradient. Example 4, find the coordinates of the points where the gradient of the tangent to the curve y equals 4x cubed plus 2x squared minus 6x plus 4 is 50. Okay, so that means we know that the gradient is 50, hence dy by dx is 50. So when we find dy by dx, we're going to exchange our dy by dx in for a 50. Let me see what we're going to do. So let's find dy by dx. Find the points of gradient of the tangent of the curve. Dy by dx equals, so 3 times the 4 is going to be 12x squared plus 4x minus 6, and then that 4 disappears. So we're going to let dy by dx then equal 50. So we're going to have then 50 equals 12x squared plus 4x minus 6. So how are we going to solve that? We are going to take the 50 over to this side, so we will have 12x squared plus 4x minus 56, and then I'm going to write my equals 0 over to there. We can divide through everything there by 4. So we divide by 4, we get 3x squared plus x minus 14 equals 0. And now then we can kind of split our middle term if you wish, or just try and work it out. So this would have to be a 3x, and this would have to be an x, and then we'd need two things that multiply together to give us minus 14. So how are we going to get that to work? If I stick, it's a 2 and a 7 possibly. So if I stick the 7 there, that's going to give me a 21 and a 2, so that's no good. So I need to put my 7 here and my 2 here, and you can see what's going to happen there. That's going to give me a 6, that's going to give me a 7. So I'm going to make that one a plus, and that one will be then a minus 2. If you want to split your middle term there and I have an extra couple lines of working out, that's 100% fine. Please don't let me put you off doing that. But that's our way then of doing that, okay? And that equals 0. That means 3x plus 7 equals 0, or x minus 2 equals 0. That means x is, I would subtract 7 from both sides and then divide by 3, so it's going to be minus 7 over 3, or x equals 2. It asks for the coordinates of the points where the gradient of the tangent of the curve is 50. So we've just found the x coordinate, we now need to find the y coordinate. So we're going to be substituting into obviously the original one. So y equals 4x cubed plus 2x squared minus 6x plus 4. So whenever x, let's see this okay, is minus 7 over 3. This is a bit messy, but let's do it nonetheless. We're going to have y equals 4 minus 7 over 3 cubed plus 2 minus 7 over 3 squared minus 6 upon minus 7 over 3 plus 4. Maybe you want to take my word for this or not, please stick that in your calculator. Minus 7 over 3 cubed is going to give us what, minus 343 over 27 times n by 4. You end up with minus 50 and 22 27th. You wouldn't want to be doing this every day. 7 over 3 squared then times the 2 going to give us 10 and 8 ninths plus minus 14 plus 4, and it gives us then a y coordinate of minus 49 and 25 27ths. My goodness. That means the coordinate where one of the coordinates where the gradient is 50 is going to be minus 7 over 3. Oh, what have I done? Put a bracket there. Minus 49 and 25/27. We've got to do the other one here as well. So whenever x is 2, it's going to be easier. Y is 4 upon 2 cubed plus 2 upon 2 squared minus 6 upon 2 plus 4. 8 times 4, 32 plus 8 minus 12 plus 4, and it gives us y equals 32. So we're finally there. Our other coordinate then is 2, 32. Let's take a look at our next example. Let's go and park. So our example, find the coordinates of the point where the gradient of the tangent to the curve is 34. A wee bit hard to see there, but that's okay. So what does that mean? If the gradient is 34, that means that dy by dx equals 34. So let's find dy by dx. 6x squared minus 18x plus 10. And we're going to let then dy by dx equal 34. So we're going to have 34 equals 6x squared minus 18x plus 10. Taking everything over to the other side, 6x squared minus 18x minus 24 equals 0. I hope you're okay with that move. I just like having a 0 over on this side, but it kind of was, we're taking 34 then from both sides. So we want to solve this quadratic equation. Plenty of ways of doing it. We could complete the square, we could factorize it, we could use the formula. I'm going to try and factorize because a spot there that everything divides by 6 to make our life a little bit easier. Giving me then x squared minus 3x minus 4 equals 0. Two numbers that multiply together to give minus 4 and add to give minus 3 are going to be x minus 4 and x plus 1. So that means x minus 4 equals 0, or x plus 1 equals 0. That means x is 4 or x is minus 1. Similar to the last one then, we need to find the y coordinate, which is always annoying, but we have y equals 2x cubed minus 9x squared plus 10x minus 2. So substituting whenever x equals 4, at x equals 4, we're going to have y equals 2 upon 4 cubed minus 9 upon 4 squared plus 10 upon 4, take away 2. 4 cubed is 64 times 2, 128. 4 squared is 16 times 9, 144. So take away 144 plus 40, take away 2, gives us y is 22. So our coordinate then for this one is 4, 22. Our other one is whenever x equals minus 1, so that means y equals 2 upon minus 1 cubed minus 9 upon minus 1 squared plus 10 upon minus 1 minus 2. Minus 1 cubed gives me minus 1, so that's going to give me a minus 2. Minus 1 squared gives me 1 times minus 9 is minus 9 minus 10 minus 2. So y then is minus 23. So my coordinate there is minus 1, minus 23. And those are the 2 points then where the gradient of that particular curve is 34.